This is either getting a strike or not getting a strike. So basically we've got chance of getting a strike is 0.15. It's two possible ways of doing it. So it's going to be binomial distribution with 10 bowls. So we'll put the probability of a strike. So we use variable S is distributed binomially to make sure we've understood the question. And we've got 10 bowls and the probability is 0.15. And now we want to find the probability. That's now to write down the probabilities. We get the probability gets no strike, so S equals 0. And in effect, we're looking at a probability of 0, 1, 2, 3, 4, 5, and all the way up to 10 up there. So we want to find out no strikes is just one particular event. So we're going to get a binomial PDF for one particular one, and we do that, we'll get 0.196874. So that's approximately equal to 0.19197 to three significant figures. Then we get part B, she gets exactly 3 strikes. We just want a 3-strike one, so probability that S equals 3, just that bar. Binomial PDF again, set it to be 3 with a probability of 0.15. We get 0.1298337, or approximately, I'll slide that down a bit so it doesn't interrupt the rest of the writing, or which is 0.130 to 3 significant figures. I'll mark this up as 3 significant figures too. Part C, she gets more than 3 strikes. So more than 3 strikes, that's 4 or above. So to get 4 or above, CDF now for between, so that's 4 up to 10. So the probability that S is greater than or equal to 4 is 0.049996 ... which is approximately equal to 0.0500 to 3 significant figures. Now we want the probability in 3 bowls, so part D, she gets a turkey. Well, if she got 3 bowls, you have to get strike, strike, strike. So this is now turkey is distributed binomially, 3 attempts and 0.15 for getting a strike, and write the probability that T equals 3. So that's just a single value. So we just want to look for, because the only one we can get with this is strike, strike, strike. In effect, there's only one way of doing it. So it's a PDF of 3, binomial PDF of 3 with a probability of 0.5 gives us 0.003375, and that's actually the exact answer. I can leave it as that. And then she gets at least a double strike. Getting a double strike is a bit more difficult because she's doing 3 different bowling events. If we look at the sample space, you get strike, not strike, strike. That gives her, that doesn't work. Not strike, strike, strike works. Strike, strike, not strike works. And strike, strike, strike works. So we've got 4 different options. This one is not allowed. And if she only gets 1 strike, nothing can work. So there's only ways of getting 2 strikes and getting them successively so she gets a double strike. So this one and this one are the same probability. It's a non-strike, 0.85, multiplied by 0.15 and another 0.15. And so is this. If we think about it in a probability tree, we could go strike, not strike, strike, not strike, strike, not strike, and again strike, not strike, strike, not strike, strike, not strike, strike, not strike, and we're effectively looking at doing strike, strike, no strike, 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 not strike, 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 and I can't do strike, not strike, strike. It's not a probability, and so now these are the same as doing this one and doing this one. And then if you want to do this one, it's the one at the top, which is 0.15 cubed. So I now need to add those three together. So we get the probability of double strike with our 3 attempts is 0.041625, which looks right because it's bigger than this one, because a turkey should be harder to get than a double strike. So turkey is included within that.